Welcome to Brain Vision.
In part A, we want to figure out what the applied force is on these crates so that we get a constant velocity. So let's go ahead and draw the combo system force diagram. And so we have our mass here. In this case, it's MA plus MB because this is the combo system. We have the normal force up. We've got gravity down, which I'm going to label the mass by M total, where M total is equal to mass of A plus mass of B. I have our applied force, which I'm just going to call F, and it's to the right. And then friction force is to the left, which I'm going to indicate by a subscript little f there. Now, by Newton's second law in the y direction, we get immediately that the normal force is equal to, forgot my g here, it's equal to m total times g, because it's not accelerating in the y direction. This means that the friction force is equal to m total times g times mu k, since the friction force is just this coefficient times the normal force. Now, the crate in the horizontal direction is moving at constant velocity, which means its acceleration is 0, which means that the sum of the forces in the x direction is equal to 0. This equation here implies that the applied force is equal to the friction force, which we found was equal to the total mass times g times the coefficient of kinetic friction. And so that's the answer to part A. In part B, I'm just going to do block B. And so the force diagram here, we have the normal force up. We've got the applied force to the right still. It's the same magnitude that we just found. Gravity is now just mb times g. And we have two forces to the left. One is tension, and the other is the force of friction on block B. Now this force here, the applied force, is what we just found in A, but this friction force is not what we found in part A, since this is just the friction force on block B. And we're just doing block B here. And so Newton's second law in the y direction again gives N is equal to mBg. And that means that the friction force in this case is equal to the coefficient times mBg. Now, sum of the forces in the x direction is equal to 0 implies that our applied force is equal to the tension plus the friction force, which implies that tension is equal to our applied force minus our friction force. And now we can plug in what we found here in part A and what we found here, right here. When we do that, we get mu k m total times g minus mu k mb, it's a k, times g. And this ends up being mu k times the mass of A times g. And that's the answer to part B.